I wanted to give you a little bit of extra help with shifting your demand and supply curves. You should have a handout that looks something like this. Now all of our graphs are going to start out the same way. We should have price on our y-axis and quantity on our x-axis. This quantity is both our quantity demanded as well as our quantity supplied. Your demand curve should be downward sloping because it follows the law of demand. When prices are high, the quantity demanded is low. When prices are low, the quantity demanded is high. This means they have an inverse relationship. The supply curve is generally upward sloping. It follows the law of supply, which says that price and quantity supplied are directly related. This means when prices are high, quantity supplied is also high. And when prices are low, the quantity supplied is low. We first need to find our equilibrium point, labeled E1. Our equilibrium point is the place where the demand curve and the supply curve intersect. At that equilibrium point, the price is price P1 and the quantity is quantity Q1. I've put little stars by them to show me that they are important prices. They're the prices that are associated with our equilibrium point. At this unique price, my quantity is both my quantity demanded and my quantity supplied, and they're equal. The graph asks us to increase demand. So I'm going to draw a new demand curve to the right of my old demand curve and call it D2 for demand curve number 2. What you can see going on here is that at each and every price, my quantity demanded has increased. So I have a whole new curve. Now what happens to equilibrium once my demand curve has shifted? Well, my new equilibrium point is point E2. At point E2, I have a new equilibrium price, price P2, and a new equilibrium quantity, quantity Q2. We can see that our equilibrium price has actually risen, while our equilibrium quantities have also risen. Now remember, this is our quantity demanded as well as our quantity supplied. So if we shift the demand curve only and we increase it, then our equilibrium price will rise as well as our equilibrium quantity, both quantity demanded as well as quantity supplied. Let's do a supply curve shift. Again, our graph is going to start out in the same way. We have price on our y-axis and quantity on our x-axis. The quantity is both our quantity demanded as well as our quantity supplied. We're going to draw our standard demand and supply curves, downward sloping demand and upward sloping supply. Then we need to find our equilibrium points. Our equilibrium point is where demand and the supply curve intersect. The price associated with this equilibrium point is price P1. The quantity associated with this equilibrium point is quantity Q1. And at this quantity, quantity demanded is equal to the quantity that's supplied. This graph asks us to decrease the supply curve. That's a shift to the left. Our new curve will look something like this. At each and every price, quantity supplied has decreased. What's our new equilibrium point? Our new equilibrium point is the point where the second supply curve, S2, intersects with our original demand curve, D1. This is the point E2. At point E2, we have a new equilibrium price, price P2, and a new equilibrium quantity, quantity Q2. So if we decrease our supply, or shift the supply curve to the left, we'll find that we have a higher equilibrium price, but a lower equilibrium quantity. Now let's put the two of these concepts together. Let's shift both demand and supply at the same time. In this situation, we have our demand curve and our supply curve both increasing. The only difference between the situation on the left and the graph on the right is that in the left graph, we have our demand shift is greater than our supply shift. But on the right graph, we have our supply shift is greater than our demand shift. Let me show you what I mean. First, we have to start out with our standard graph. Downward sloping demand, upward sloping supply, price on the y-axis, and quantity on our x-axis. We need to find our equilibrium points, E1, and our equilibrium price and equilibrium quantity that's associated with each of those. Now, in this graph, our demand and supply curves are both going to increase. That means they're both going to shift to the right. On the left graph, we need to make the demand shift larger than the supply shift. And in the right graph, we need to make our supply shift larger than our demand shift. It should look something like this. Do you see in the left-hand graph, we have a large demand shift in terms of the space in between the original demand curve and the new demand curve, but we only have a very small supply shift. Our supply has increased, but only by a little bit. It helps to kind of exaggerate the difference between these two so that you really see that one is larger than the other. This will help you make sure that you get real results in your analysis at the end. Now, we need to find our new equilibrium points. Our new equilibrium points are the point where the new demand curve and the new supply curve intersect. So where D2 and S2 intersect. In the left-hand graph, it's point E2. And at E2, the price associated with it is P2, and the quantity associated with it is Q2. You can see that our price has increased and our equilibrium quantity has also increased. Now what's going on over here on the right-hand graph? On the right graph, we have our supply shift is greater than our demand shift. So our supply shift is large while our demand shift is small. What has happened to price? Well, in this case, price actually fell, whereas our equilibrium quantity still rose. To summarize this information, we can fill out the chart on the back of your handout. This is where supply increases and demand increases. So it's this first little square right here in the upper left-hand corner. We find that when supply and demand both increase, that our equilibrium quantity always increases. You can see that here in these two graphs, that the quantity is increasing here and here. But what has happened to price? Well, in one situation, the price went up. And in the other situation, the price actually went down. We would say that the equilibrium price change is actually indeterminate or can't be determined or is unknown. You can work through these sets of graphs and fill out all of the information in this table. This is a helpful tool for you to study by. I don't suggest that you memorize it, but instead you memorize the process of how to draw your graphs so that you can always figure out the right answer.